So taking that time just to slow down and plan a little bit. There's also a gentleman, he has a lot of videos out on the internet. He is from Singapore. His name is Dr. Yeet Ben Har. If you look him up, he's got stuff all over the internet. And then he's also got a website, I think it's called Maths. This is Maths, no problem. If you ever go to European countries, they call it Maths with an S. And I believe that's why he calls it that. Okay, so I want you to take a moment and think about this problem. Jake is 3 years older than Kyla and 2 years younger than Larry. The total of their ages is 41 years old. Diagram it, however you would solve it for however you would like to solve it on a piece of paper. This is not for me. This is between you and that piece of paper that you're writing on. And then I'm going to show you a video of how it's solved when we use methods similar to what they use in Singapore. And I know when you see things like this, our brains can go, oh my gosh, how in the world? Too much information being thrown at me, too many numbers. Okay, so I'm going to show you this video. It's a little bit hard to see, but this young lady is going to solve this with the methods that they would use in Singapore. And just think about how you might have been taught this to solve this particular problem, or how you might teach it, and how things might look different when they diagram it and make it use a little bit of visualization for this. And drop it in the chat here.
Hi there, my name is Sarah from Addictive Math Inc. And in the last video, we talked about what bar modeling is and how we can use it to solve word problems. And so in this video, I'm going to show an example of a word problem that we can solve using a bar model. So we have a problem here, and it says that Jake is 3 years older than Kyla and 2 years younger than Larry. The total of their ages is 41 years. How old is Jake? Now we can solve this algebraically, but we can also work this using a bar model, which is geared towards younger students or more visual learners. So the first thing I'm going to do is read back through the first sentence and draw out a picture to describe it. So Jake is 3 years older than Kyla and 2 years younger than Larry. So I'm going to draw out bars to represent the ages of each of the 3 kids. So we have Jake, we have Kyla, and we have Larry. Okay, so Jake is 3 years older than Kyla. So I'm going to draw a bar to represent the age of Kyla. And then I'm going to draw another bar for Jake that's 3 years more than what Kyla is. So there's Kyla's age. And then Jake is 3 years older. Okay. And Jake is also 2 years younger than Larry. In other words, Larry is 2 years older than Jake. So Larry is whatever Jake is. So I'm going to draw that there. Plus 2 more years. Okay. And then it says that the total of their ages is 41 years. So what I'm going to do is I'm going to draw a bracket and write out the 41 here to represent that all of these quantities that we've drawn out total to 41. Now we have some that are known where we have a number inside and we say, oh, this quantity is 2. And we also have some that are unknown. And in fact, our unknown quantities are the same So in terms of algebra, if we were working this algebraically, that would mean we would have one variable that appears 3 times. In this context with the picture, what I'm actually going to do is remove the nodes. So this is our equivalent of isolating x. So I'm going to take all of our nodes. We have 3, 3, and 2. So that's a total of 8. So this whole thing is 8 right here. And I'm actually going to get rid of it. So when I remove this 8, I need to also subtract it from our total over here. Okay, so now I have a new statement. I'm saying that 3 of whatever this quantity is equal to 41 minus 8. So let's simplify this over here. We do 41 minus 8, which will give us 33. And then we're saying that 3 of these bars is equal to 33. So that must mean that each individual one, since they're all the same size, is 11. 33 divided by 3. Now we can go back and solve for the age of Jake, because none of our quantities are unknown anymore. So, going back to our original bar model where we said that Jake is 3 years older than Kyla, it originally looked something like this. Now we can say that Jake must be 14, Kyla must be 11, and Larry must be 16. And that's how we arrive at a solution, finding the age of Jake and his friends using a bar model.
Okay, share with me your thoughts on that. What did you notice was maybe different about the way you might have been taught to solve that? What's different about the way you might have been taught to solve that if you were in maybe your high school algebra or your middle school math class? What's different about the way she solved this than what you might have been taught to do, or what you might have taught others to do? Sorry, I'm having technical difficulties.
Oh, I was going to say that she did a lot more math reasoning, and I think I just did computation.
Yeah. And if you've ever taken Foundations of Math or any of our courses, we talk a lot about the concrete, representational, and abstract. This is a very representational way to solve this problem. It makes perfect sense because you can see it. You have that visual of how old they were. What my brain kind of goes to, and I think what we oftentimes want our students to go to, is they should have started writing x plus 3 plus x plus 3 plus 2, and then solve it, linearly, like she said. It's the same thing as like isolating x, but she didn't need to do that. She was able to isolate it and do it in a very visual manner. And when it comes down to it, it really doesn't matter how our kids solve word problems at all, as long as they get the correct answer. And we push a lot of times for kids to go right to the abstract, right to solving it, and to do it fast. So the basic steps of this are pretty much, this is kind of what they tell kids in Singapore. It's not like what's hanging on a wall in a classroom. It's kind of what's ingrained in them and how they learn to solve them. So you read the question, you write an answer statement. So if this was asking Julie how many apples Julie had, the presenter that was talking said, have your kids say Julie had apples or blank apples, because somebody in that classroom is going to yell out 25 or whatever the number is. So you want those kids who can solve it very quickly to hold back on their answer. Then, just like we looked at the math main idea, we talk about who and what are we talking about. Okay, here we were talking about some people and their ages. And notice she drew their start. She drew a box for Jake, and he had +3, and she drew a start. She chunked it out into reasonable chunks. So I can see Larry is here, Jake is 3 years older, and then so the last person, can't remember their name, was 2 years older. So visually she was able to see it, and then she went back and made sure it made sense. So I think we can all agree. This is what Dr. Van Haar says about students in mathematics is we don't need them to be fast. We have technology in the United States and all around the world that's fast, right? Calculators are fast. We need children to be thinkers. We need children to spend more time thinking about and reasoning through the context of the problem. We had a presenter here was talking about his spouse is an engineer, and when he asks, when he talks about mathematical problems, he immediately takes out a piece of paper and pencil, but doesn't always write down the numbers. He starts drawing pictures. So that's something that these people, career mathematicians, they draw diagrams, they write pictures, they use visuals. So why would we not encourage our students to do that in school? So we need them to think deeply about things. We can give somebody a calculator, but just because they have a calculator doesn't mean they can reason through and solve that. And I think that young lady in the video we just saw, she did quite a bit of reasoning about that problem and real logical reasoning. So if we look at this problem, I'm going to kind of show you the steps that we might walk through. Okay, all right, here we go. I tried to be fancy with my PowerPoint, but it didn't work. So Tim got 13 marbles at Walmart and 12 marbles at Target. How many marbles did he get all together? So with your students, you would say, we read the problem. If it's a longer problem, I would encourage reading it twice, reading it 3 times, kind of like the 3 reads. And then as a group, we say, Tim had marbles all together. Tim had marbles all together. And then notice I labeled it. This line right here represents the start. So I would actually write in here, and I didn't do that, 13 marbles at Walmart, 12 marbles at Target. And the reasoning behind this is what Dr. Van Haar says, if I can picture it, I can understand it. So we can understand, we were talking about IEP progress monitoring. People can understand graphs. Even if you're not in that particular, in education, you can understand graph of progress. Well, we can understand visuals in mathematics, even if we're not, quote unquote, very good at mathematics, we can understand those visuals and then understand them. So what the picture is saying here is we're going to somehow put 13 and 12 together. I think we talked about, or I don't know if I showed this group a video. I think we did Julie's video, Julie Russo's video of, she showed the kids a picture and had them talk about what could this be about. Make up a story for these. And that's a good exercise to do with kids too. Okay, so I like PolyPad. If you've never seen PolyPad, this is what it looks like. The website, put a link there, and the slides are pinned in the chat. But PolyPad has what's called number bars. And you can put in any number that you want to. So like if you look right here, I put in this problem. My family baked 15 cookies. 8 cookies were eaten. How many cookies were left? So you can go here. I'm going to delete this one and this one. You can put the number 15 in here. Oops. Keep clicking. Put the number 15 and it will give you a number bar with 15. And if you need to, you can even change the colors of it. If you need to put in like another number, you can change the color down right here as well. Okay, so if you want to kind of play around with PolyPad for a moment and think about how you would solve this problem. Yeah. Oh, sorry, I was trying to. I'll show you. If you put the number, if you need to make a number that's not here, you just put the number in here. So we could have done 12, and then we could have done the 13 marbles. It changed colors for me, but if I wanted to change this color, I could have gone to like purple or something. So, excuse me, think about that, play around with that in PolyPad and see what you can come up with as far as how you might solve that problem. Okay, does anybody kind of want to share their thoughts or what they came up with? It's getting out my notes that I took from this presentation. I was kind of feverishly taking notes there, but I wanted to see what she did with this one. But anyone have any ideas of what you might do? And I think there is a pen option in Polypad too. Yeah, you can write in Polypad. If not, I will share the example. Okay. Okay. All right. So I'm going to start with my 15 cookies that we had, right? Okay. And then we have 8 cookies here. Now, of course, I'm going to label right here. I might look a little funny reaching up for my screen, but I'm going to label this. We baked. One of the words she asked the kids a lot was, is this the big part or the small part? Yeah, you would absolutely subtract. But if we have kids who are having trouble visualizing that subtraction, okay, we baked 15 cookies. 8 were eaten. And what happens when we eat the cookies? They go away, right? So this is just a way to visually represent that eating or that subtraction. And then we know this bar would be worth 7. Sometimes with some students, depending on where they are developmentally or in their learning, you might actually need to draw out a bar like this and put the 15. I'm not going to put 15 in there, and then actually cross out the 8. Any visual representation is going to help them to understand that word problem. You will be surprised at what you think might be an easy word problem for you. Might be a very difficult word problem for our students. So let's go back to talking a little bit about keywords. What's tricky about this word problem if we just told kids to focus on the keywords? Yeah, altogether, it's a wordy question. I'm going to show you one in a minute that my brain kind of went on overload when I looked at it, right? And that's sometimes a lot of the times what we do as teachers, we look at word problems and we're like, oh, I'm not going to teach that. It's too wordy and it's hurting my brain. I can't imagine what those are the kids. But altogether, what kids might do, what might kids do if they see a 6 and a 4 in the word altogether? What are they going to do if we ask them? Yeah, they're just going to add. Is 10 the answer? No, No, good. Thank you, Janice. 10 is not the answer to this, but I guarantee you, if this is on a multiple choice test, 10 is going to be one of those answer choices. Because they're assessing the student's understanding, not necessarily just their mathematical ability, right? So if we look at this, keep this in mind here. I'm going to go to Polypad, okay? All right, so the question is asking, Braden has 6 toys. So that's our start. We're going to start with Braden. And I'm actually going to write on here, or I'm just going to put a B, that these are Braden's toys, okay? Then I know that Trevor had 4 more toys than Braden. So I'm going to start with 6 here, but I'm going to add 4 more on. And those are Trevor's toys, right? So if I had done this correctly, we would have said they have blank toys altogether, right? So they have toys altogether, okay? So here is where now I can add them together. Oh, 6 and 6 is 12 plus 4 more. The answer is 16, not 10. And one of the points that Dr. Van Haar makes is we would never give our kids a comprehension. Yeah, I love Polypad. Polypad's got a lot more digital manipulatives in it too. Let me just make my pitch for it. While it's still not blocked, there's number cards, there's number lines, there's all kinds of fractions and stuff that goes down here. It is made by the same people who do Desmos, which is Amplify Learning. I think they acquired Desmos. So check it out. There's also some free fluency resources up here in the corner. So that's my Polypad sales pitch. Just remember, this is great to use in front of your kids. If you can actually get your kids using some sort of bar model, or they make some blank bars or sentence strips, something like that. If you have that in front of the kids, but just remember, this is for you to demonstrate, and this is a lot of it is representational. I think kids can get on it too if they want to, but for some of the younger kids, it can be a little bit tricky. But we would never give our kids a comprehension passage and say, okay, just read the key words, right? And then you're going to answer these comprehension questions. So why in math do we do that? And I thought that was a very good question that was brought up during that session I attended as well. I thought, well, why in the world? Yeah. We tell students, say, we wouldn't give them something to comprehend and tell them just to read the keywords. We want them to be able to understand what's happening in the story. Same thing in math. We want them to be able to understand that, make the schema, and then do the math from there and really understand what's going on. And sense making, going back and making sure the answer makes sense. If I got some giant, big number answer, maybe I'm doing something wrong with this and I need to go back. Okay, so if you've had foundations of math, you don't have to give me your answer. Actually, I don't want you to give me your answer. But think about this. There are 6 students for every principal. Which one is the best equation that matches the statement? You don't have to give it to me. Just think about it. I can't remember the exact percent, but a lot of American educators got this wrong. A lot of people chose A, which is not the correct answer. Why did they choose A? Because we're seeing 6 for every principal. That must mean 6 times P, right? Okay. Well, if we put that in, let me go over here back to Polypad. If we let's say we were to put that in a chart, okay? So let's say I start diagramming this and see if this makes sense, okay? Students, principals. So if I say S equals 6P, whatever number I got to put in here is going to equal S. So if I put 1, I have 6. No, wait, other way around. No, I'm sorry. A lot of people picked B. instead of A. A is the correct answer. So if I were to do this the other way around, every time, whatever I put in here, there's the eraser. Okay. If I were to put in here, if I were to put 1 student and 6 times S would give me 6, 2 is 12. Is this making sense? Who are there more of, right? There's supposed to be more students, right? So the correct answer is actually A. If we were to take a moment and diagram it, say we put principal here, and then we have students branching off of it, then we could really set up a diagram and have some conversations about sense making and saying, okay, does 6P, S equals 6P make sense? Or does P equals 6S make sense? Because there are supposed to be more students than principals in the school. So why do you think, what are some of the reasons that you think, let me go back to that problem. What are some of the reasons you think American educators got this wrong? And I just want to say that the way we were taught math was not wrong. We were taught very procedurally. It's a cultural issue when it comes to how we are taught mathematics. It's not anything that's your fault. We tend to teach the way we were taught. We were teach that way. So yeah, the algebraic thinking, variables. You know, a lot of us just like to look at things and pick that A, B, C, or D that's on that multiple choice test. But notice every one of these are plausible. Every one of these answer choices here could have been a plausible, what they call a plausible foil. The wrong answers that might make sense to students. So yeah, a lot of people did get these incorrect for that reason. That, you know, it's so when we know better, we do better. So it's not your fault if you're sitting here. I remember taking foundations of math and they were talking about subtraction. And I thought, I taught every one of my students wrong. I got to go back and fix them. Don't worry about that. It's a cultural problem. We've realized a lot of it. We're doing there's a lot of research going on in education now about, you know, why is America lagging behind so much? It's the way that mathematics is taught. We're really going to, we really should be focusing on giving our students deep learning strategies and thinking strategies, not doing 25 word problems, but teaching 2 or 3 word problems well, so that when they encounter other word problems, they can do better. And a lot of times we weren't taught to diagram word problems. I was told draw pictures, but I really wasn't told how to draw those pictures when I was in school. So, all right. So here's what I want you to think about. Richard has some cows. His dad has 20 more cows than Richard. If they have 120 cows altogether, how many cows does Richard have? This one hurt my brain. And actually, I think we're going to get done a little bit early today, but take a moment. I'm going to give you about a minute and a half to just kind of think about this, process it, draw some bar models, see what you might do with it. Okay. I know, I want to remind you, this is a safe place. Okay, divide by 2 and subtract 20. Okay, did you model that somehow, Janice? Okay, you thought about place value? Okay. All right, so let's start with, we're going to go here with, I'm going to go back to the drawing here. Okay. So I want to note that in PolyPad, if you put in really big numbers on the number bars, so I might just actually start, I'm probably just going to draw them. But if you use the number bars and you put in like 100 or something, it goes all the way across your screen. So I would say keep it for low numbers and just draw for the higher numbers. So I'm going to draw this one out. So what would be, let's talk about, we read it. Okay. How many cows does Richard have? Our answer statement would be Richard has cows. Okay. So Richard has cows. Okay. All right. So then what is our start? If we go back to the problem here, what is our start? Do we know how many cows Richard has? Okay, I think you might be onto something there, Crystal. Do we know how many cows? But right off, do we know how many cows he has? No, we didn't know, right? So we know Richard has some cows. That's what we're trying to figure out, okay? We know that his dad has 20 more cows than Richard. So this is, I'm going to make sure I label Richard and his dad, but dad's cows are 20 more. And what was the total? Yeah, if you're starting to introduce your kids to algebra, you can introduce this. You can introduce X, or you can just leave it blank as a bar model. Either way, they're going to get the correct answer. So we know that all together they had 120 cows. Oh, I'm writing, y'all can't see. Okay, so I know all together they have 120 cows. This is where you can introduce X if you want to. So remember the young lady in the one before, in the video previously? She said, well, I went ahead and took this away, right? So she actually erased. I'm just going to scribble. And then she subtracted 20. Oh, that leaves us with 100. If these up to here, they are equal, just like we do in instructions of equality, up to here, they're equal. How many cows does Richard have? He has 50, and his dad has 50. So 50 plus 20 equals 100. A lot of times kids will do a lot of guess and check with this, but you want to make sure that your answer makes sense. One of the reasons that, so yeah, dad has 70 and Richard has 50. We're going to add that together and make sure that we go back and check our answer. Yeah, so dad has 70, Richard has 50. One of the reasons that we encourage kids to go back and check is just to make sure that there's making sense in that answer, or and then when you have your start and you have something that's comparing with like 20 more, we want to emphasize to the kids that up to this point is equal, and we're just adding those 20 on. So it's kind of one of those things where I'm like, wow, it makes so much more sense when I see it in the diagram. And it goes back to that, if I can see it, then I can understand it. So it's just teaching students those learning strategies so that they can apply that to any relevant word problem that they come across. So I'm going to go back to, this is Dr. Van Haar, and I think he's going to go over in here his website, Maths No Problem. I think I shared these in the resources, but he's just going to talk about some of the ways that bar models are used. And I'm going to just kind of leave you for next time to kind of research and play around with some of these things and let me know what might work for you. But this is his video about, he's going to be talking about some coins and how he would teach a kid to solve a problem with some coins. And it's one of these kind of complex comparison problems like we just did.
My name is Banha, and we are going to look at one of the mathematical ideas children learn in school. Bar models are diagrams, rectangles, used to represent quantities. For example, I have a word problem. It goes something like that. I have some coins. Some are local coins. The rest are foreign coins. I have a total of 80 coins. I have more local coins than foreign coins. I have 8 more local coins than foreign coins. So that's a typical word problem children solve in school. I have local coins and foreign coins. In total, I have 80 of them. I have 8 more local coins than foreign coins. So, how many local coins do I have? How many foreign coins do I have? Children can figure out a situation like that through the use of diagrams that we call bar models. So, they would use rectangles to try to show the number of foreign coins and local coins, both of which we do not know the number. Does this show that I have more local coins than foreign coins? This is not a correct diagram because this shows me that I have equal number of local coins and foreign coins. So what could I do to show the information that I have more local coins than foreign coins, in particular 8 more? What should I do to this diagram or that diagram to show the correct information? I suppose I could do this. Would this be an improvement to the diagram I had earlier? Does this show that I had 8 more local coins than foreign coins? It does, doesn't it? So this is bar model. Bar model is a diagram where we use rectangles to represent quantities. And sometimes the quantities are unknown. Now, I also know that the total number of coins I have is 80. So all these stand for 80. What could I do? I think the first thing I can do is to subtract away the 8 from 80. 80 subtract 8, that gives me 72. So this is 72. If this is 72, what's the next thing I can figure out? That's right. I think I can figure that this is going to be 72 divided by 2, which of course is 36. So 36 and 36, that makes 72. So this is 36, that is 36. So depending on what the question asks of me, I can then give the appropriate answer. If the question asks me, how many foreign coins I have, that will be 36. However, if the question is how many local coins do I have, then it would be 36 plus 8. So that's one of the ideas children learn in school mathematics. That's bar models.
I think I mentioned to you before, whether you call it bar models, whether you call it structures of equality, whether you call it a diagram, no matter what you call it, either way, keep it consistent, but either way, it's going to benefit our students, being able to model those things. And I would start as simple as possible. But if you take the time to really look through some of those sample EOG questions, there are some in there that are rather complex that you might want to work with. So these are our, we have some our templates in our My Math lessons. This is a bar model resource from EAI. I think they gave me this sample at the math conference as well. So these are some bar models that they sell. They're tiny, I mean, really little, but you can draw a race on them. But I would just say, you can cut strips of paper too. But there are some really good lessons in here and some good word problems you might want to try with your kids. So there's some good ones here that you might want to try. So I'll link that in there for you because I like free stuff. Maths No Problem is one of the Singapore websites. If you're on here, there is some free I think there's some free PD, but I think there's also some paid PD. This is just that concrete CRA, concrete pictorial abstract. There's some things you might want to look through. Maybe if we have a snow day, you have some time, you can look through those. I don't know that we're going to have a snow day, but we do have 3 hours early release tomorrow. And of course, I put in there numberless word problems and structures of equality. And I'll just share that. There's the link to that bar model resource there as well. These are our trainings. So you are welcome to look them up in Wake Learns. Our next fluency training is on a track 4. They're tracked out right now. Our next training is on a track 4 workday for the fluency. But if you've attended the fluency training, use the kits. I know, Jordan, you mentioned that. I am hearing some good things. And if you ever want to show it off and show us how you're using it, we'll be happy to come out and see you. We'd love to see it in action. The next time we meet for this PLC will be February 6th. Same time, same SES math. And always look for the updates if the schedule changes or anything. I send them out through the both Wake Learns and the SES Math website. So, wish it was on my A game a little bit more today. I've got this stuffy cold going on, and I'm going to go set up for our Foundations of Math, which we're going to try to cram into a few hours tomorrow morning. But I hope you all have a wonderful weekend. Please be careful in the snow or ice, whatever it is, and I hope that you stay warm and get some rest. Y'all enjoy your short day tomorrow. Thank you.